Hi, everybody, and welcome to Precise Mistakes. As makers, we explore the unknown and use the elements to produce a variety of objects. From countless hours of experience to the endless time fixing mistakes, the art of learning becomes our main obstacle. Precise Mistakes brings you the weekly insight with a range of panel members to provide you with the learning experiences they've found along the journey of making things. From decades of experience to the newbie in the room, we provide a deep range of perspectives that'll keep you on the edge of your seat for information. Thank you for coming tonight, guys. And tonight we are talking about CNC designs and concepts. Along with me, we have Mike Mirsky in the house from Mirsky Custom Woodworking. Mike, if you just want to say hi to everybody so those listening in and not watching can know your voice.
Hey, how's it going?
Good. And Mike, what kind of hobby work do you do or professional work do you do?
I'm still in the Army, so my business, Mirsky Custom Woodworking, I do kind of on the side, and I do a full range of woodworking, everything from small crafts up to furniture and home improvements.
Yes, and if anybody listening has seen one icon thing I think of you is those wooden American flag coin holders. Really cool. And for anybody looking for anybody on the panel in here, go ahead down to the description below, and there's links to everybody down there to their media, and you can trace through everything they have from there. Thank you very much, Mike. Next up is James Jacob, or also known as Shogun Jimmy. James, you want to go ahead and say hi to everybody and let us know what kind of stuff you're into?
Yeah, hi guys, Shogun Jimmy here. I'm just into anything that you could create in your shop with your hands. I just absolutely love that kind of activity. Whenever I let my mind free on like a couple chunks of wood and put it together however I want. Time just seems to sit still, but also kind of run through my fingers all at the same time. And that's just the best part of my day is when I get out there and do something.
Awesome. Always looking for those solutions.
Yeah.
Cool. Thank you very much and welcome aboard.
Yeah, thank you.
Next up, we have Tony Rulo of Hillview Wood and Metals. Tony, you want to go ahead and say hi to everybody and let them know what you do?
Hi guys, I'm Tony Rulo. I am a machinist as my day job, and I'm a hobby maker, woodworking, 3D printing, things, welding, metalwork, anything.
You do some amazing precision work with metal. Some of them you may be known from your branding, irons that you make. Also recently, a lot of hand planes that have been going around with the nice metal dovetails in them.
Yeah, I've been getting more and more into tool making, and that's turning into a side business, which I hope to grow. Awesome.
Well, thank you very much, and welcome on board. And Shogun Jimmy, by the way, that huge mallet is what I think about when I think about you. I missed that, sorry. Thank you very much, Tony. And next up is Joe Whitaker of Average Joe's Joinery. Joe, you want to go ahead and let everybody know what you do and such?
Yeah, all right, Tom. Yeah, well, as Jason just said, I'm Joe, and I've got Average Joe's Joinery is my YouTube channel. And as far as whether it's a hobby or a profession, it's merely just a hobby for me at the moment. But I do have that ambition to actually turn it into a career at some point down the line, sooner rather than later if possible. But yeah, it's purely just a hobby for me at the minute, something to keep me busy, keep my mind busy, and like everyone else has said, really, it's just the passion for the craft.
And on the bonus of that, like Shogun, you get to kind of, jump in and do what you feel passionate about that day, as opposed to following the buck at the paycheck.
Exactly. Yeah.
Welcome aboard. We also have Jason Roush from Roush Woodworks. Jason, you want to say hi and let people know the extensive list of things you're into?
Oh, okay. Yeah, I'm Jason Roush, and I'm on YouTube as Roush Woodworks. Facebook is Roush Woodworks, Jason Roush on Twitter, and all the others, I think. Anyways, a wide range of stuff I love to do: woodworking, electronics, machining, some CNC, amateur radio, just a wide range of things I love to do. Model trains is another big thing I love to do. So those are kind of my big hobbies that I spend way too much money and time in.
I definitely like to tinker, and
Yes, I do.
I've learned a lot of soldering skills from you. I mean I'm amateur in electronics, but I've caught some of your soldering videos that you put out, and I learned a lot from those, and went, oh, I'm doing it wrong.
Well, you got to start somewhere. That's what I told when I was a soldering instructor. That's what I told all my students. Said you got to start somewhere.
That's why you're so good at teaching it.
Well, I've been soldering since I was about 7 or 8 years old, so it really came with the experience.
Awesome. Well, welcome aboard.
Thank you, brother.
Last but not least, we have Mr. Dave Gatton here from Gatton Woodworks. Dave, you want to go ahead and let everybody know what you do?
Thanks for having me on, Jason. These days, you'll find me probably out there in my garage cutting DIY CNC kits for folks, for hobby CNC enthusiasts.
Yeah, you actually sell CNC kits to people. Like, do you sell the controllers and everything as a package, or just certain parts?
Just certain parts. The GarageWorks brand that I sell is pretty much a rolling chassis, and then of course I have recommendations of what they can use, but a lot of people shop around and get their own stuff. Some people like to use the drive box and stepper motors that I recommend, and others like that have an electronic background like to make their own. So,
and I like the option that you provide. I'm sorry.
Well, I was just going to say, yeah, I just kind of leave it up to the individual, because some people, just want to go plug and play, and others like to tinker and solder and stuff like that. So,
and like I was going to say, I like what you provide. I mean, I could buy the parts from you, but if you're far from me, I could literally buy the plans from you and have someone print them on a CNC themselves. That's pretty cool. And also, you have a weekly show on Saturdays, Gatton, on your YouTube channel, which everybody can get the link down below. You want to talk just a quick bit about that?
Yeah, I've been doing a little show on Saturday nights called CNC with Dave, where we just kind of get together with a bunch of hobby CNC guys and gals, and just kind of hang out and talk about different things related to hobby CNC.
So I don't catch it as often as I would like, but I see a lot of great topics going by. And one guy actually in our chat right now, Mark Lindsay, on there a lot, and he has a lot of good shows on his YouTube channel describing how to use the software and design concepts and things. So I just want to point that out. All right, thank you very much, guys. Really appreciate you being on the panel tonight, and we have a lot to talk about, so let's get right into it. First thing I wanted to drop in is conceptualizing your ideas. So right from the start, first of all, maybe where these ideas come from, maybe out of necessity, out of customers, different things. But once you get these ideas and the concept that you need to build, what are your basic first approaches and thoughts and considerations into those steps? Let's maybe go ahead and start with Tony, if you don't mind. You're on my left.
Design as far as a new product, or how to fixture something, or
very good question. Anything really, but let's say a new product or a solution to something that you're designing. Well, let's pick something then. Drawer pulls. I recently had to make I didn't have to, but I designed drawer pulls for Mike Fulton's Woodshop, MF Woodshop, and in that there was multiple layers and his logo and different things to consider. So what if I were to give you my logo and a basic design concept, what would be the first kind of steps that you take to putting that together?
Well, especially with like the branding irons that I do with the logos, your cutter can only get so small, so you have to dial in on how much detail can I get in the drawer pull. If it's an engraved drawer pull, what is my material? Is it being supplied, or am I using something off my shelf, or have they requested something? Go ahead.
Okay. All right. Well, let's say we take a my design has a piece that's too small, maybe for something that you can literally cut. How do we get around those kinds of constraints? Or can you?
Sometimes it's just a matter of moving something a little away so the cutter can migrate. Like if someone has two stars next to something and they're just a little too close, if I can move them just a 64th of an inch, then the cutter can get through and it's more pronounced. You know, work with the customer or your design to make it user friendly.
Okay, and maybe also could you change things like bits and stuff?
Yeah, yeah.
Let's say like an engraving bit as opposed to a smaller bit.
Yeah, yeah. You go to a V bit, and then you can also change. You can go from a 45 to even a 30, which gets you a steeper angle. That gets you down in there further, and you can get a finer detail.
Because one thing that I generally run into as a problem, and I'm going to say it right off the bat, I'm genuinely asking these questions. These aren't leading questions. Engraving, let's say, if I need to do lettering on things, I have a hard time doing small letterings, mostly because like a P, the center of the little knob of the P, is always going to break out or something, or my bit's just too small and breaks from the material. So those things like using your V bits and changing your design just slightly to adjust are ways that you use to get around those things.
Yeah, and I mean the deeper you go with the V bit, the wider it cuts. So you can use that to your advantage. Where very fine detail, you make a very shallow cut enough to where it shows up to the eye, and then if you need to widen it out, you can go a little deeper, and that'll produce a wider cut.
Nice. Does anybody have anything they want to add to that, or anything kind of approach they take?
So with my Mickey Mouse bowl, I ran into a major issue with that. Cutting the inside cut was really easy. I used like a 1/8 end mill. Cutting the inside cut was easy. If you think about the Mickey Mouse head, the silhouette, where the ears meet the head, there's some very distinct sharp points. There's 2 of them for each one of those junctions. When you're doing the inside cut, you can cut those with a fairly large cutter. And in my case, I was using a 1/8 inch end mill. When it came to cutting the plug part with black walnut, that was virtually impossible because I couldn't get even an end mill even remotely small enough to get those really sharp corners. And I realized this about halfway through the process, and that's why I decided to use the epoxy infill when I did that bowl for the first time. I've since come up with a method now that I could use where I would cut just the head and then cut the plug for that, glue it in. Once that's plugged in, go back and mill the 2 ears separately, and it's going to cut into the first plug a little bit, then cut out those 2 plugs and glue those in. So it'd be a multi-step process, but I would have gotten up those perfect sharp cuts or those perfect sharp corners at the junctions of the ear to the head, and I would have been able to do it with all wood, which was my original intention. So that's just like Tony was talking about. Sometimes there's just not enough clearance, and the end mill just can't get small enough.
Right. So actually, something, and correct me if I'm wrong, something I recently heard or seen and found was you can use V curving as a type of inlay. So you have the opposite V curve on like the points coming out, and then the matching V curve in, and inlay them together and clear first sharper points and precision kind of rounded areas.
Yeah, and think of like when MTM Wood does a really intricate inlay in an end-grain cutting board. He does that, and he can get those really sharp corners. In my case with the turning, I can't do that because even if I'd done that, the first 32nd to a 16th inch of material that I took off, that right. V carved part would start getting wider and wider and wider, so I couldn't use that as a trick.
Gotcha. So with that said, there's different kinds of software that are used, and what are the kinds of softwares that you guys use do you use like a certain kind of software for one thing, another kind of software for another, or do you always use the same kind of software? Maybe Joe, you want to go ahead? I know you have an X-Card CNC. If you guys want to also say what kind of CNC machine you have, just so that if people have that machine, they can relate, maybe.
Yeah, well, like you just said, I've got the X-Carve CNC from Inventables, and at the moment I've got the old spindle on it, so it only does like 1/8" bits, which I've very struggled to find those kind of bits in the UK. So I've still mainly been playing around with Easel, which is the free software, like web-based software from Inventables. I have been looking at VCarve and VCarve Pro, I think it is, which is quite expensive, but it allows you to do a lot more in terms of 3D work. But I think I need to get like either a DeWalt or a Makita router added to it so I can use some 1/4" router bits that would be more substantial for 3D work. But like I said, at the minute it's just been that free software which has got me by up until now. But in the future I do want to get a bit more professional with it.
So I have noticed Easel stepped up a little bit in functionality and usage within it. I still don't use it though. I use G-code.
All right.
I've skipped that right from the start. And you still use that stock spindle as well?
Yeah, still the stock one. I've been struggling to source the DeWalt in the UK. That's been my biggest issue. It seems to be out of stock everywhere. I've got the mount for it. I've got everything to go. I just can't get the machine itself.
Okay. Wow.
Yeah. That's the UK for you.
Figure out a way to get you a DWP 611.
That's it.
Anybody else? What kind of software do you guys use? Mike?
I'm using the, well, my CNC, I've got the GarageWorks CNC by Dave Gatton. I've got his 48 by 48 inch. And for a spindle, I'm running the DeWalt DW611. For software, I primarily use VCarve Pro for it. There is sometimes when I'm trying to get a vectorized image into it, I might use Inkscape, which is a free imaging software, to just transfer it from like a JPEG or a bitmap to an SVG file, and then pull that into VCarve Pro and kind of finalize my design work and then create my tool paths.
How do you generally get your initial SVG files and things that you're talking about there?
Well, it really depends on kind of the project. You know, a lot of times I'll have a client that'll want either a logo, either laser engraved or carved into it. So a lot of times they'll provide me with an image, but usually, you know, they really don't know they need it to be a better quality image. So I end up having to go kind of behind and doing a little Google search, trying to find a high definition image. Like I said, then I pull it into, you can do that on VCarve Pro. I just found sometimes, depending on the image quality, Inkscape's a little better to do the SVG, to create the SVG file, and then I just import it back into VCarve Pro.
That's something worth mentioning, I think, is, you know, I started on Inkscape and I learned vectors with it, and I learned how to manage the vector nodes and use it how you're supposed to use it. And then moving to Vectric Aspire, the whole section of vector editing, it's pretty much, it's like the same concepts and everything's pretty much exactly the same for trying to edit and manage a vector image anyway. So anybody looking to say, oh, I can't afford that right now, you start using Inkscape and get used to those things. I find that was a good way for me anyway to easily take that higher end software once I could finally get to it.
Yeah.
How about sorry?
Oh, I was just saying, and before I got VCarve Pro, I was using a free online CAM software, very similar to Easel. And so I started off doing that with Inkscape and then transferring it in. So yeah, so but you know, when I finally went and was able to afford, you know, one of the Vectrics program, it was, like you said, it was kind of very, very intuitive because it was pretty much set up the same way for stuff like that.
How about Shogun Jimmy there? What do you use for software and preparing your designs and your concepts?
Yeah, I have a V-Carve desktop. It came with my CNC Shark. I got the model just above the Piranha, so it's like a 12 by 30 or something like that, where it's a plastic frame. And I like kind of get my image, and then I run a tool path around the image, and then I'm either going to cut down around it or on the inside of it. And that's kind of the focus and the way I kind of transfer. It's a real slow and tedious process for the most part. But just to go from concept to getting that image on the computer, I'm new. I think I'm the newest person on the panel to CNC. I've only had mine for 3 to 4 months. And I'd rather actually lathe than CNC for the most part, because I could get my hands in there. But once you kind of get into the CNC, it's actually not so bad after you get the kind of the basics down. And that's kind of, I almost feel like I got firm ground now. So
nice. Yeah, I found that part of the learning curve as well. It was like kind of 4 or 5 months before I really started feeling like I kind of know what I'm doing. and it's a lot of that curve was the software and learning vectors and learning just not just like making those vector files, but then how the machine reacts to what I've designed and what I've put together.
Yeah. The 2 different sections is there's like the CAD, the computer aided drawing sections, and then the CAM. And both are kind of their own realms of how to deal with the computer and really getting your idea into the, from your head into the computer. And trying to get it to cut the way I want has been more of a learning process than I've ever expected. For Valentine's Day, I made a box of chocolate, and just cutting the purple heart thing out, I made one mistake, because in my head, it's like the bit is 3 inches long. It should be able to cut 2 inches deep. And I actually overextended my bit, and it fell out midway through cutting. And it was just something that I never even imagined could happen. And unfortunately, I know you're supposed to supervise the machine, but I came in the house to use the restroom, and I came back out there, and my machine is squeaking and popping, and it was just freaking me out. So I had to run in and hit the panic button and stop it. So those little things you learn.
Actually, something you mentioned that I just want to bring it up. I usually use Google Hangouts. I set up a little camera on my CNC machine, and then I just send myself the link, and I come up to my main office here, and I can watch it right from my screen, and I can hear it down in the basement running. Yeah. So if something squeaks, I look, or if, I take a glance over and check every once in a while.
Yeah.
I've actually got a security camera with it's got night vision capability, so I don't even have to have a light on in my shed, and I leave my bedroom window open so I can hear it as well. Just very similar.
Yeah.
Nice. Little wire running from there to your panic button to stop it.
Let's see.
Anybody else? What do you guys use for your software? Dave, how you doing? You're quiet over there. Oh, it's because you're on mute.
Yeah, well, I hit it, and it was so slow, I hit it twice, I guess. No, I use VCarve Pro. I've been using VCarve Pro from Vectric for, I don't know, 10 or 12 years, something like that. And always been real happy with their stuff. It was easy for me to learn, because back when I was working full time, that's kind of what I did anyway, was draw in CAD and program CNC machines. So it was just kind of a real easy software. It didn't take me long at all to realize just how good that software really is. So
VCarve Pro, do you use that just for VCarving, or is that for many things, many types of applications?
Well, you can use it for quite a bit of things. I mean, it even has the wrapping feature. I've done a video where I made kind of a homemade rotary axis, and make spindles and wrap text around the cylinder and stuff like that. And of course, obviously VCarve, for signage and things like that. And it's also great just for cutting 2D parts, pockets and pick drilling and all kinds of stuff. So it's really versatile software.
Nice. And Tony, I apologize. I realized I started off with an awkward question for you to kind of like just jump right into it. So maybe I'll come back to you. And what kind of software do you use? And
I have a Shapeoko 2 that I upgraded, I guess, to an X card. I just use Easel for that. But with as far as SVGs and stuff like that go, I use Illustrator a lot, Adobe Illustrator for mine for when I do the branding irons, because then I transfer it into a DXF, an Autodesk CAD file that I bring into my CAM software for the big CNCs at work for my day job when I do my branding irons after hours. And I use Gibbs CAM as the name of the software. It's an industrial CAM software. But for my CNC at home, I just use Easel.
oh, okay. See, oh yeah, Shapeoko is Inventables or were, so they works with it.
Yeah.
Eh?
Yeah, I think the Shapeoko 3 was when they broke off, I believe.
That was my first CNC also, Shapeoko 2.
So I noticed everybody here in general, it's common, and maybe it's obvious to anybody using a CNC, but anybody may be looking to learning a CNC machine. Why is it that everybody here tends to lean on vector type files or images or SVGs and those kinds of things? Anybody care to answer that for me?
Well, I'll chime in and say I do not do that. I'm more of a traditional toolchain thing. I use Dassault Systems CAD. I draw whatever everything I'm gonna do in CAD, and I drop that into Vectric Cut 2D. I don't have VCarve. I have Cut 2D, and then I drop that into Mach 3, and I use Mach 3 to run my main X2 mini mill that I converted. I do use Easel for the X-Carve that I have, but I find Easel extremely frustrating most of the time. I wish that I could just run everything in Mach 3, which I could if I was to redo. I'd basically have to redo the X-Carve to do that, and I'm not entirely convinced that putting all the money into it to make it do that is worth it, because I don't think the X-Carve is all that great. But that's just my one personal opinion here. But yeah, I don't typically mess with the vector stuff because I'm usually doing a lot of 2D panel cutting, housings, electronics housings. So I do a lot of that through my X2, and that's where just Cut 2D and CAD works really well for me. And then, of course, like I said, Mach 3 is just phenomenal, and I know Dave uses Mach 3 quite a bit, so I think he knows what I'm talking about when it's just the best machine control you can get for the money.
Cool. Yeah, no, but I think like when it comes down to it, though, I think your second step there, it still ends up using vectors, and the only thing I was trying to point out to maybe new people, Mark Lindsay caught on there. It's an industry standard. He said, I don't fully understand, but I do understand that it allows, because a vector file is drawn in line after line after line, it allows the simplicity of tool paths to be created that allows the CNC machine to know exactly where to run the tool. And so, and correct me if I'm wrong or add anything, feel free to add anything, guys.
It has to do with the way the image file is constructed. Most image files like JPEGs, bitmaps, and stuff like that are created are pixels. So when you expand one of those files out, the pixel just grows. Everyone's seen like the Nintendo or the old style stuff, that 8-bit graphics look, kind of like, now the kids playing Minecraft and stuff, that pixelated look. So that's what would happen if you tried using a bitmap or JPEG image file to try to design on the CNC. Is if you expanded it, all you would do is you would get a kind of the block where a vector image, you don't have that pixelation, just the way the kind of how that image is kind of put together, I guess.
Yeah, because it follows its own line, and then if it wants bigger, it just makes a bigger line, a wider, like an outer line, bigger and bigger, and can grow exponentially. But Jason, you do bring a good point, and another point question would be, I hear some of you guys using CAD software versus, say, the VCarve, where you're designing kind of in a flat perspective. And so I guess just to point out to people, it's a CAD software is more of 3D kind of feel, and the other kinds of software are more like 2D, like flat kind of drawings. Does anybody, maybe Jason, you want to jump in and what the difference is in using, like, I've been considering, for instance, using Fusion 360 lately, and taking the time to actually really learn it well so that I could use that as opposed to using Vectric Aspire 8. But I don't know the difference in why I would do that, other than allowing me the ability to make a 3D image as opposed to a flat 2D image, which I can do in Vectric, I understand, but you can be more detailed, I guess, or something in Fusion 360 type CAD software.
Well, for me, like I said, I'm doing a lot of 2D stuff. So I never saw a need to do anything more than straight CAD. Even when I'm doing like signs, if I'm cutting out a sign for somebody, it's still really 2D when it comes down to it, because I'm just cutting, I'm just plunging the cutter and cutting that, cutting whatever that shape is at, that's really all I'm doing there. The only reason I see a need personally for the 3D stuff, whether it be SketchUp or Fusion 360 or where, is when I'm moving to a 3D world, i.e. 3D printing, or I'm trying to machine a part that, let's say I'm machining, I don't know, a bracket for something that has multiple sides to it. Then that makes all the sense in the world. But then, and Tony can speak much more in authority on this, is when it comes to a 3-axis, a 4-axis, 5-axis CNC that's capable of doing that. When you're talking about a Cartesian plane type of CNC, that's still really 2D. And I guess VCarve, they've mastered using a V cutting bit to get that kind of 3D cut, if you will, using kind of a 2D system. And like I said, Tony could speak much more authority on that.
Tony, do you want to add to
that? Yeah, I believe the industry calls that 2.5D milling, where it'll actually use the V bit like that. But yeah, generally I program, set up, and run a 5-axis Haas, and we use solid parametric models to program, because there's just so much math going on there with complex surfaces that it would take forever to program. So we go off the model instead of just a flat 2D drawing, where we can actually pull. Sometimes we even just go to a face of the model and just pull 2D features from it to drill holes and cut pockets, or else sometimes it's a complex surface, like if it's a radius curve that goes from one plane to another, where the mill actually has to follow it. But most stuff is you're picking from 2D planes.
Okay, so even though using CAD 3D software, generally bringing it down to a 2D kind of perspective for cuts.
At least for what I do, 75 to 80% is, like I said, if you have a complex part that has pockets on all different sides, you're indexing the machine, and then you're dealing with a 2D drawing and going from there.
Anybody else have anything else they want to add?
Yeah, well, if I could just add something real quick, Jason. I use VCarve Pro in half for a long time, but as far as drawing, I've used SolidWorks for a lot of years. And I personally am not if I'm just going out to my shop to do some kind of woodworking project, I've never been one of those guys that could just go out there, without a plan and just start making stuff. I just end up making a bunch of firewood. But what I like to do is draw everything in SolidWorks, especially if it's something that I'm going to assemble. And I do it just like I was doing sheet metal for my old job. Create assembly drawing and part drawings. And then I take those drawings out to the shop after I've saved a DXF file as a flat, and to use in VCarve Pro, do my VCarve Pro post processor and create a G-code file and take it out there. And basically, I know that because I modeled it in 3D, I know that all I have to do is cut those parts, whether they're wood or plastic or whatever they are. I just have to cut them to the print that I've made, and I know everything's going to fit. So I'm just one of those guys. Because of my background in sheet metal, that's just the way you do things, and I kind of do the same thing in woodworking too. Is I have just a set of drawings and a plan before I ever go out to my shop and know what I'm going to make.
So that'd be another bonus to using a CAD type software. Is not only can you just design things for your CNC machine, but you can also conceptualize for handmade things that you just want to run, cut some boards.
Exactly. And I'm not a SketchUp user because I've used SolidWorks so long. I just haven't felt the need to try to learn SketchUp, but I know there's a lot of guys that use SketchUp to do their projects, and then then they can create the plans as well, and they sell the plans for things. There's a lot of folks on YouTube that to create their plan drawings.
So you guys create these plans on software and you develop these things, and I've heard from a few of you guys you use DXF files. Anybody care to explain exactly what the DXF file is, and why is it that it seems to be the most standard thing everybody wants to pass around or use as a format?
I'll just say real quick that the DXF file has been around for years and years and years, even back when AutoCAD was the industry standard. When I say AutoCAD, I'm talking just 2D stuff. And the DXF stands for Drawing Exchange Format. It's just a format that they came up with that's easily used by lots of different CAD things. It's and it's still pretty much the industry standard when you're talking about 2D drawings.
So if you're looking to share your files with people, DXF is probably the way to go.
Yeah, because you really don't have to worry about if they have the same CAD software as you. If they have any kind of CAD software, they're probably going to be able to read a DXF file.
Gotcha. Nice. Is there any features that wouldn't be available in DXF that you might want to use a different format for, or is it just it's so standard that you pretty much that's what you want to stick with?
I would say you'd probably just stick with it, because most most programming software, not just the Vectric VCarve, but even in sheet metal, that's usually what you're looking to import, to cut it on a laser or whatever.
Yeah.
Okay,
One of those reasons,
sorry, go ahead.
Oh, I was going to say, one of those reasons you get a little more detail with the DXF is, so with an SVG file, you can actually, between systems, can have some difference, because the vector part of the scalable vector graphics is, all it is a bunch of points, and then there's either curved lines or straight lines connecting those points, and that's why on an SVG file you have all those anchor points that you can move. Well, depending on the software, and I've even had where I've gotten an SVG file from someone else that they designed, and just some of the stuff was kind of wonky when I imported it, where I think just the way the DXF file is made, that even sharing in between different softwares, I've never seen an issue with either scale or proportion being off.
Does anybody have anything they wanted to add to that, or? Okay, so the next thing I wanted to talk about, we got our file designed, we're ready to go, and now we're looking at our bits. We mentioned V-carving, engraving, you got 2D, 3D, and we got inlays, you got all sorts of kinds of ways to cut things. Now, Let's just go with standard types cutting. So you want to cut out some standard parts with some detail and a few different sizes. So let's choose wood, a hard wood that we're cutting into. How do you, or actually any material, we'll leave it open that way. How do you choose your bits that you want to use? That's one thing I'm glad when I got my CNC machine, I got a ton of bits with it, because learning how to cut on the CNC, one of the biggest things was going through bits like water. Oh, it's too fast. Oh, it's too deep. Oh, that's not spinning the spindle fast enough. That's, XYZ, whatever happened, I broke a lot of bits in learning that process. So if you could give somebody some advice if they're new to the CNC or anything in choosing their bits, how would you go about that?
I would use the biggest bit you can use possible. The most rigid setup. That's what you always want to try to shoot for, is rigidity. The smaller the bit, the more the bit can flex. So try to use it as large a bit as you can for just pure strength.
Okay, and what about like different options that we have? There's upcut spiral and straight flutes and fish tails and ball nose. How do we know which one to pick? So we pick our nice thick bit that won't break, and now which one do we use for cutting out, say, our profile cuts and things like that?
I would imagine if you're doing deep pocketing, you'd want an upcut bit to get the chip up and out versus a straight flute. The ball nose, that's more, I would think, for detail-oriented work. It all depends. If you're doing the engraving or detail, you would go with a ball nose or the V-cut, the V-groove. But, if you're profiling, I would just go with a standard straight, or upcut bit.
Okay, and the difference between those, something I've noticed anyway, on some materials, an upcut bit will leave a lot of frillies, obviously because it's pulling everything up. And in those cases, maybe sometimes, especially like hard maple, I've found that straight flutes they just leave a cleaner edge. Is there a reason, or is it simply that fact that a harder material, is that even a rule? Like a harder material, maybe use a straight flute, or should I be using an up spiral because it gets all that material out of there?
I'm thinking more of the machine. The metal world is where my strengths are. I don't have a ton of experience cutting hardwoods on a CNC.
Well, I guess metal's pretty hard. So do you want to? I guess maybe it isn't the same. But like, I guess what I see is the difference is when I'm cutting a profile cut, if I use a up spiral, it will take out the waste easier and it leaves less in the track. But if I use a straight bit, it does cut a cleaner bit track along the top, but it fills in the line that leaves behind.
Yeah, you're constantly having to deal with chips. Yeah.
Yeah. So is there a difference or a preference or an industry standard, I guess, that should be followed?
Yeah, that's wood, and that's out of my realm, really. Like I said, I'm just at hobby level with the wood CNCs.
How are you guys?
A lot of it, I just recommend people usually do a lot of trial error because, there is some stuff out there that, some people will get really scientific, and I think a lot of those are guys that, previous machinist experience, and they'll start talking about chip load, and they'll start throwing all these terms out there that, really end up just confusing the beginner, because then they start hearing all these terms, speed rates, and, all this stuff, and how much of a depth of cut am I supposed to do, and they kind of get overwhelmed. The best thing I always recommend is take it easy at first, and then you can ramp it up from there slowly. But it's really kind of matching, just like any other woodworking, is matching the tool to the piece of wood. Whether you're cutting a part out in plywood versus you know, cutting out a Mayan calendar and a piece of mahogany.
Maybe you don't make that your first cut.
Yeah, it's second or third, but
yeah. So like Tony's saying, nice thick bit at first, and like you're saying, start off a little slow, and just kind of ease up to the speeds, and you can find what you get comfortable with and what your machine can handle, and what it'll take. And especially, and that dynamic will change based on the material that you have or you're using.
And yeah, the material and also what you're doing. If you're cutting, you know, here one of my first actual projects I made on a CNC, and I did this with the Shapeoko too, was I made a Longworth chuck for my lathe, and I basically cut out a part, well, several parts in plywood. You know, I could have put a you know, a little 1 32 inch bit in there, but I would have probably been buying a lot of 1 32 inch bits. So kind of the Tony's point was, you know, for something like that, you know, my spindle used a 1/4 inch, can take a 1/4 inch bit. So put a 1/4 inch end mill in there, give it, you know, a leg up by having a little beef in there while you're cutting, you know, those parts out.
You still have that design file?
I do. And for 3 equal payments of $19.95 plus ship now.
Oh, perfect. Tony, you want to send that over to him there?
You know, in some projects, you know, we're talking about the different bits. You know, I sometimes I'll do some 3D carvings, and I'll remove most of the waste with a larger, like, straight cut bit, or, you know, again, like Tony, going back to Tony's point of using the bigger bit, and then I get all that waste out of there, and then I'll do a second tool path where I'll definitely kind of get all the 3D detail in there by using like a tapered ball nose bit. That would take, even if that ball nose bit, you could have removed that material, it'd take you, I don't know, easily 10 times longer.
Which the 3D carving takes long enough as it is.
Yeah.
Okay, and maybe as a round table here, can you? I'm sorry, I totally got into the subjects, and usually I'll hit a couple round tables, and I didn't do that. So I guess maybe what I'll do is I'll do a round table here and say, what are some general problems you typically run into on a complicated or new design? So what are some like pitfalls in general? It doesn't even have to be a new design, but some pitfalls that you've run into. And maybe if you have either a good scenario, bad scenario type response where you could say, you know, either or, I found a solution, this is what I did, or disaster hit, and this is what happened. And I threw it in the campfire. So maybe and as a round table, I'm gonna spread that around. So if you guys, I'll start with Joe. Good or bad experience, a good solution, bad solution, and yeah, what were a general problem that you ran into, and how did you solve it?
Well, I've got I forget the exact dimensions, but it's roughly the 4 foot by 4 foot X-carve from Inventables, which I always thought would be above and beyond the size that I would ever need, until I got asked to make this Power Rangers kids bed. And I was thinking I'm going to be doing it all by hand, maybe cut out the parts on the bandsaw and stuff. But the person I was making it for says, I've seen you've got a CNC. Can you use the CNC so it'll be perfect? Well, of course, the kids' bed's a bit longer than 4 foot long. So I was trying to figure out how can I do it in different parts and then fix together those pieces, but still keep that 3D aspect, getting everything to line up. And the way I came up with the solution was long-winded, very basic. It was literally just creating my image using GIMP 2.0, which is kind of like Photoshop, and then I literally chopped them in half, but with say 2 inches either side. So when I'd cut them and I'd stack them together, it would create a finger joint that I could then glue up, and it would give it that strength, because it was cutting it out of MDF. It was like 12mm MDF, so it wasn't going to be all that strong on its own, and it definitely wouldn't be strong enough just to have a butt joint. So by cutting 2 inch off center, cutting the left side, then cutting the right side, gluing those panels up, and then joining the finger joint, that seems to be how I got round it. But it was a lot of tracing, a lot of messing around with the design software. So I'm not sure if there's any other alternative. I could have gone down that route, but I managed it in the end.
That's a good plan, though. You make where your size restraint, make it the joinery. That's interesting. I actually have a sign. Somebody asked me if they can make it, and they want a big sign, but it won't fit on my CNC. And I was like, well, I'd have a seam through the center. How do I do that? Maybe just make it part of the joinery.
That's it.
How about Dave? How about you?
I don't really cut a whole lot of stuff other than kit parts, and that's pretty much a proven program. So I don't really run into any big issues that I have to solve. I guess probably the biggest one for me is because of the blanks of plywood that I'm cutting are pretty good size. You know, trying to get the material to get flat, you know, clamping it down and trying to get it to stay flat everywhere. Although I am cutting all the way through, so even if it's raised up in some places or bowed or something, it's not that big of a deal for me.
Okay, thank you. Sorry, I was trying to. Mark Lindsay put tiling on there, and it just got me thinking. And sorry for the pause there, but I am actually intimidated with tiling, and that's again coming back to that whole things are too big. It's just, I guess it's like you were saying with the sheet metal, Dave. You learn to just trust it after a while, maybe. But for me, I have a hard time trusting the CNC machine, and because maybe that's because I don't trust myself yet in my design ability to make it that precise where it's going to turn out. I can just go, it's going to turn out perfect. I'll just run it. I know that's going to work. I can't do that. But anyway, thank you very much. And maybe next, Jason Roush. Do you have a general issue you ran into, and a complication or anything, good or bad, and how you solved it, or
well, so
bad story?
For me, it's accuracy and tolerances. And I think one of the biggest problems that CNC owners run into is something called backlash. And you can have backlash whether it's belt, or in my case, my good CNC uses ball screws and ball nuts to try to eliminate as much of that backlash as possible. And just to explain backlash really quick, basically what backlash is that whenever you rotate, let's say a threaded rod, there's going to be a little bit of from rotating one direction opposed to the other direction. And backlash can be eliminated quite a bit. Like I said, with like ball screws and ball nuts, for example, it's extremely accurate. So I find if I'm doing a precision part and or a precision cutout, let's say I'm cutting out a window for an LCD, which I do a lot of. A lot of my products I'm doing that. Or actually, that's a bad example because that can be off a little bit. Let's say it's for a button that protrudes through a panel, where the button's got to come through the panel so the user can access it. Backlash can cause that to either be off a little bit or to be too tight. Let's say the hole was cut just a little too tight because of the backlash in the CNC itself. So sometimes that's part of the tolerances, knowing the tolerances of your machine, knowing that, okay, I can cut that hole at exactly 4 millimeters because I know that the button is 3.8 millimeters wide. But I know that with a little bit of backlash my machine has, I should add like 0.2 millimeters. And if I do that, my hole's going to be a little bit bigger, but I'm going to have a tolerance that that button is going to be able to protrude through and have clearance and not rub against the panel. So that's the way I deal with it with my machines, but that's a very specific kind of problem that I have with the type of stuff I typically do with my CNCs.
But that's a good point, and something for people to pay attention to is that kind of play that might be, or backlash, if I understand correctly, is the same thing kind of in, you know, whether it be screw driven or belt driven, whatever it is, there might be a little bit of play in your machine. You got to learn that, for especially for small precision things like that. Thank you.
Yeah, every machine has its own little characters and little idiosyncrasies that you learn about, and you just learn to work around them.
Yeah, I had a similar problem with that too. On one of my latest projects, I did a nice sign for someone, and it had just a circle ring, and I was doing a male-female inlay thing, and the male ring that I had was just a little bit bigger. And the way I had to solve that, because it was like a one-time piece, I mean, I'd have to start all over with a new ingrain kind of cutting board piece to make that ring again. I just cut a small kerf in it, and I just tried to remove just enough material to where it shrink down to fit down into the female groove. And it just frustrated me with my machine, because here, you know, I thought I had a very tolerant, you know, steady machine, and it made that ring just slightly big enough to where it would never fit in. I would have spent hours and hours of sanding if I had not cut the kerf, and it kind of just drove me nuts. But I did finally get it in. A nice mallet, a couple clamps. She got in there. Yeah,
I've tried sanding things down before to fit, and it never turns out good. It doesn't look like it's inlaid on by a machine, that's for sure. Mike, you had an experience you want to share?
I have a long list of experience. My biggest problem is my day job. Keeps me from getting in my shop. But no, I kind of look at, you know, everything I do is kind of problem solving. So, you know, I think it is, you know, I mean, I could go on for days with different issues I've had. You know, the inlay issue, getting inlays to mate up just perfectly and stuff like that. I mean, and I just kind of go when I come up with a problem, and you know, just try to go through some problem solving steps to figure it out.
Yeah, like one problem with inlays I've had is they don't fit, and some, I could bring it back to the bit thing, using the biggest bit. That's what I would do. I would, okay, well, I want to make the pocket, so I make the pocket with my big bit, but then I make the inlay has little curves, so I use a smaller bit. Well, then I realized afterwards that makes different size curves. Things don't fit. There are a lot of things, and I get jealous with watching some people jealous, but I wish I could do that. They do the pocket, and then they do the what would you call it, the negative, I guess, of it, or the negative is the pocket, but anyway, and then they just put the two boards together and they fit perfectly, and they just like seal together, and then they sand it down, and it exposes the inlay perfectly.
And I will say that those people, what they don't show on camera is the trial and error of getting it to fit. Vectrix in their software and their inlay part of this thing, they actually have a thing where you can kind of play, and it allows you to kind of tweak the pocket to receive that that inlay a little bit. And then once you kind of, you know, you learn with different bits you're using what kind of tolerances is, and you know, you might have to adjust the pocket by, you know, I mean, we're talking very minimal measurements. Once you get that down, yeah, then all of a sudden you can start. But there's some trial and error. I always, every time I'm doing like an inlay piece, I try it on scrap wood and you know, do it a couple times on there. You know, I can't even count how many times I attempted that on my actual project. That you know, eventually I learned to do some test cuts first.
Like Tony was saying at the start, maybe you got to take your design and just tweak it a little bit to make it appropriate for what you're trying to do. And with that, we'll end it on Tony. If Tony, do you have an example of a?
Yeah, mine's short and simple. I did a backgammon table or board that opened up, and I wanted to do the inlay where they're all the triangles, and I wanted to do them on the X-carve. So I cleverly cut all these strips of veneer that were the same width as the triangles, and then I stopped and realized I had no good way of holding them. So I, racked my brain, and I went to an old, at least from what I've learned, a machinist trick. I broke out the carpet tape, the good heavy fiberglass double stick tape, and that worked, and it worked out. So double stick tape is your friend. It's a little sketchy at times, but it's your friend.
I actually used double-sided tape once to hold down my project, and I stopped doing that because when you go all the way through, it gums all the tape up into. Yeah. So what I did to alleviate that is I cut strips around, so hopefully I would miss it. That fiber woven carpet tape, that's the good stuff. But yeah, if you lay it down and it gets in that cutter, it gums up. Well, thank you very much, guys. Not enough time in a night. I mean, look, Dave Gatton's on his 52nd episode, and he's still going on about CNC stuff. Can never cover it all. If you do want to learn more, I do recommend you go check out his show because it is excellent source of information and really great people on his panel weekly. Thank you very much, everybody. I really appreciate being here, and I appreciate you sharing your insight with our audience. And if you're interested for next week, we are talking using social media platforms to educate and inspire. We'll be talking with Izzy Swan on his Toolmasters Association, Jamie Page, great, hilarious guy, and his approach to expanding things in his reach to his audience, as well as we have a few other people lined up, and it should be a good show next week. So, as always, I am Jason McGinn, your host, and this has been Precise Mistakes, every Friday night, 7 o'clock Eastern live. If you miss it, I'm on SoundCloud as a podcast if you're in the shop and you just want to listen, you don't want to watch, or you can check it on my YouTube channel at any time. And again, anybody down here interests you and you want to check out their stuff, go down into the links below and you'll see every one of them listed there. Thank you, everybody, and have a good night.